result of ingenious design, brilliant engineering and advances in science. A remarkable secret life just waiting to be discovered. Meet Richard Ambrose and Johnny Phillips. They're industrial scientists, fascinated by the commonplace objects all around us. Join them on their mission to unearth the surprising stories behind the things we take for granted. In this edition, glass. Can an opera singer's high note really shatter lead crystal? Impact testing glass to the max.
OK, John.
And putting bulletproof glass through its paces. Also, meet Sid, the computer-controlled mannequin who set alight daily to test the flammability of clothing. The secrets that lie beneath escalators. And what's inside a snooker ball.
Glass is everywhere. We drink from it, we eat off it, we build with it. It keeps the weather out and it lets the sunshine in. It's used in cars, trains, boats and planes. Glass is a critical component in satellites, computers and TVs. It can protect us from radiation, fire and even bullets. Glass is a modern-day wonder material and our need for it has never been greater. Last year, the world's glass production topped 20 billion square feet.
So, what's the secret of glass? Well, the most important ingredient is silica, which is found in sand.
Now, you can make high-quality glass using silica alone, but it requires incredible temperatures. We're talking volcanic heat.
Around 1,700 degrees Celsius, in fact, and for the ancients, generating such temperatures was virtually impossible.
The solution is to add soda ash or sodium carbonate to the silica, which reduces its melting point to a much more manageable 850 degrees centigrade. The problem, however, with glass made like this is that it's water-soluble, which is about as useful as a chocolate teacup. Watch this.
Almost immediately, tiny scales of glass start to appear, and the water takes on a distinctively cloudy appearance as the glass begins to break down. And, given enough time, around 24 hours in this case, it would disappear completely. So, what keeps glass from dissolving in water? Our third and final ingredient is lime, derived from limestone.
And that's it. It really is that simple. 3 basic ingredients.
The discovery of how to blow glass, made by the Syrians in around the 1st century BC, was a huge breakthrough. Overnight, glass became a mass-produced product with 1,001 practical uses. So, how easy is it to blow glass? Well, typically it takes 10 years of training to become a master glass maker, like Tina Dahl, and she's very kindly offered to pass on some of her hard-earned knowledge of the ancient art of glass blowing to Richard.
Right, so we've got a bubble.
Yep.
And we're just going to allow it to cool down. If this is too hot, it just wobbles about and you end up with glass like that.
I'm with you. And what are the tricks?
To start off nice and slow.
Yeah.
And to also learn how the glass wants to move. You can't really go into it and say, well, I want it to be this shape and I'm going to force you into that shape. It's liquid and it's almost alive.
So the glass is boss all the time?
Yeah, all the glass is boss, yeah.
The trouble is, you can only work the glass for a few minutes at a time before you have to pop it back in the glory hole to heat it up some more.
How do you think things are going at the moment?
You're doing well.
Yeah?
Get it on centre.
It's Johnny's birthday soon, so what is it I'm making here?
Whiskey glass.
Oh, is it? Oh, great. He'll like that.
Allowing for cooling time is vital. Any less than 12 hours and the glass could shatter.
That's it.
There's Johnny's whiskey glass. He'll be delighted with that.
One of the most important breakthroughs in the history of glass was made by the Venetians in the 15th century. By making glass, not from sand, but from silica derived from the purest white quartz pebbles, they found they could produce clear glass which was totally colourless. They called this new glass Cristallo, and it was the first time anyone had made totally clear, colourless glass. The next big development was made by an Englishman called George Ravenscroft in 1676. He perfected a formula for colourless lead crystal glass, which was made by adding lead oxide. Lead crystal is great for engraving. It has fantastic prismatic qualities, which is what makes it so good for chandeliers. Still to come, we find out how modern glass is made on an industrial scale. And it's not over until the fat lady sings. We explode a few myths about wine glasses and opera singers. Meet Sid. He's got one of the hottest testing jobs around. He's the dummy that stands in the middle of a raging inferno to test fireproof clothing, the kind of outfits worn by workers exposed to the extreme temperatures generated by industrial kilns. Sid's been created by technicians at Sartre, and Dave McCowan is his minder. Before any test, he must dress Sid. Like any self-respecting mannequin, Sid likes his bits to be covered, and putting him in a vest and pants makes the test more realistic.
I'm not sure whether the vest should be inside or outside the underwear. I'm not going to worry about that.
Sid is made of fire-retardant fiberglass. He's painted black so that his surface absorbs any heat. Tiny sensors cover his body, and they record the temperature and transmit it to a computer 10 times per second. Sid is surrounded by 16 propane burners that can blast out flames at a staggering 1,000 degrees Celsius. That's as hot as lava from an erupting volcano. And it can easily kill a person. So Sid is left to face the flames on his own.
Three, two, one.
Cooling off time. Sid's still smoking, but has he been burnt? What results have come back from the heat sensors?
In total, only 9 sensors showed first-degree burns, 9 showed second-degree burns, and only 6 showed third-degree burns.
This means that in a real fire, the suit would have protected someone from severe burns and enabled them to escape. Sid survived another flame grilling, and he's ready for more. Burn, baby, burn.
This is my favourite part of the show because I get to cut things up to show you what's inside them. This time it's a snooker ball. The game of snooker, a spin-off from English billiards, was invented in 1875 by a British Army colonel stationed in India. Now it's a worldwide phenomenon. But what's inside the highly polished ball? This ball weighs around 128 grams. When it's struck during a match, it can accelerate from 0 to 30 kilometers an hour in just a fraction of a second.
Wow, that is good cutting. It's solid. It's just the same material all the way through by the look of it.
The ball is made of just one material, phenolic resin, a rugged plastic also found in some car brake pads. The material is so tough, the ball can withstand 5 tons of pressure. More grinder action next time. I can't wait.
Still to come, can an opera singer at full throttle shatter a glass? Revealing the moving story behind escalators. And is bulletproof glass really bulletproof?
炎炎夏日的午后，跟着国家地理频道来一趟清凉消暑的旅行。